This training video is intended to provide a general description of Electric Reliability Council of Texas, Incorporated's ERCOT's process for the Real-Time Co-Optimization Plus Batteries RTC+B program. This video is not a replacement for the ERCOT nodal protocols, operating guides, planning guides, or other binding documents. In the event of any conflict, the ERCOT nodal protocols, market guides, and/or other binding documents, OBDs, shall control.
Hello, my name is Kenneth Ragsdale. I'm a principal in the market design group at ERCOT, and this presentation is focused on the battery portion of the Real-Time Co-Optimization Plus Battery project, also known as RTC+B. This presentation is about 25 slides, and throughout the presentation, there are a few links that are provided that may be helpful. The links buried in the presentation are also collected and shown on the last slide of the deck. Here is the agenda. First, we want to go over at a high level the ERCOT energy storage resource background. Where are we? How did we get here? And what is the future like? We'll do an overview of the RTC+B scope and specifically the plus B changes. We have a high level review of the final state with the plus B changes along with RTC. And then various topics including registration, qualification, and modeling, the day-ahead market, the real-time market, energy bid, energy offer curves that are submitted, current operating plans and telemetry, set point deviation, and the reliability unit commitment process and the exposure to being short. So this first slide is an overview of the changes to the ERCOT grid over the last 25 years. It shows the additions and retirements. And what I wanted to show and highlight is the sharp increase of batteries on the ERCOT system in the last 4 or 5 years or so. You can see this sharp line here. Also note the solar increase and the wind increase. In the far left-hand corner is a quick table that shows a projection by the end of 2028 based on our generation interconnection queue of what possibly the amounts of wind, PV, and energy storage could be on the system by the end of 2028. Energy storage is shown around 41,000 megawatts. This next slide, slide 4, is recent data pulled out June 1st from the generation interconnection queue. And I would note that these are the requests that have come to ERCOT from the developers. It's not likely that all this will materialize, but it gives us an indication of what's in the queue and what the developers have planned. Things to notice on this slide is the battery row, which shows 174,000 megawatts, the largest of any category. And then the solar and the wind are also very strong in the quantity that's in the queue. The bottom right-hand corner shows what a snapshot on December 1st was for the batteries for the last 7 years. And you can see over the last 7 years, we've seen a significant increase in the amount of megawatts of batteries in the queue. I would also note that included in this 174,000 megawatts is about 417 megawatts of distributed connected energy storage resources that are in the queue. There also is a pumped hydro project that's in the queue, shown there in the other. It's a little over 1,232, and we'll watch that one closely. This next slide, slide 5, gives a little more detail of how the batteries have increased on the system since far left 2012 and how we have projections out to 2029. Back in 2012, we had our first one on the system. It was an advanced lead acid battery, 36 megawatts. We created at that time a workaround called the combo model. We'll talk about that a little bit more. And then you can see for several years, there were not many additions to the system in terms of energy storage resource. But once we got to 2021, we saw a sharp increase. As of today, you can see the yellow arrow where we're about at 13,000 megawatts. And by the end of 2025, we may be at 18,000. And then for reference, at the end of 2028, we're showing 41,000 megawatts of batteries. Again, not all of this will materialize. The blue is what's actually already in service. The red here is fairly certain to materialized. The IA interconnection agreement is signed and the financial security is posted. And the green portion is a little less certain. The IA is signed, but no financial security has been posted. So those are some estimates of what might be on the grid in the next coming years. Also on this table are some milestones through the evolution. I'm not going to go through all of them, but I'm just going to point out some information on some key ones. For example, the state of charge telemetry requirement was something that we implemented back in the fall of 2018. So each energy storage resource needs to telemeter to us its current state of charge in megawatt hours, and that's information that ERCOT will use. Another key milestone was the bid to buy functionality that came in the spring of 2021. And with that, we had the energy storage resources following awards based on their bid to buys when they wanted to consume. And also we implemented the capability for the energy storage resources to update their bids to buy and their offers to sell anytime they wanted to. And that way our SCED process, security constrained economic dispatch process, will capture that most recent information they've provided and use that in the calculations. And then lastly, there is another feature called self-limiting facilities that we implemented in March 2024. On slide 6, this is a little bit of a hard slide to read, but it shows the duration information for the existing operating batteries and the planned batteries. The top two graphs at the top are about the operational batteries. The left one is the number of resources, and the right one is the megawatts. And the key takeaway to take from this is the existing operational batteries. Most of them are 1 hour and less than 2 hour batteries. We have a few of them that are 2 hour batteries. When you go down to the two bottom graphs, that is the planned batteries that we see based on our information that we've received. And you can see the planned batteries are expected to have a longer duration. Most of them are 2 hours, and there's quite a few that are more than 2 hours that are in the queue. Key thing to note is in ERCOT, the duration of the batteries is quite a bit shorter than, for example, in the California ISO, where most of theirs, if not all of theirs, are 4 hour batteries. And that's primarily driven by their resource adequacy construct. And that incents them to put in 4 hour batteries. And what this does is in ERCOT, with the shorter duration, the batteries in ERCOT are having to deal with the minimum state of charge point and the maximum state of charge point more frequently than if these were 4 hour batteries. This slide here is a representation of over the last 3 summers of the energy storage resource percent of total system-wide AS procurement in the day-ahead market. And as the number of batteries on the system has increased, as you would expect, percentage in the various ancillary services has increased, especially in regulation up, response and reserve, and the ERCOT contingency reserve service, which was implemented in June 2023. You can also see that non-spin, not a lot of batteries are providing non-spin, or at least have not done that in the last 3 summers. So key takeaway is batteries are providing a significant proportion of our ancillary services, likely to grow even more as we get more on the system. Slide 8. This is a quick picture of a typical day in the summer. We picked August 2020 in 2024. This happens to be 4 coincident peak day in August. And the graph shows 24 hours. The gray bars are the ERCOT-wide load. The blue bars is the injection from the ERCOT fleet of batteries. And the black bars is the withdrawal of the ERCOT fleet of the batteries. And you can see throughout the day, primarily in the early morning hours, you see mostly withdrawals by the battery. And then the key part is once we got to close to hour ending 19, that's when most of the batteries pushed to the grid. There were probably other batteries at that time that were carrying ancillary service and maybe not pushing to the grid, but at least providing that service. And this just gives you a general idea of what a summer day looks like. On this day, it was roughly almost 4,000 megawatts of energy storage pushed to the grid in that hour ending 19. And another key thing to note is even though the 4CP interval where we had our highest load was earlier in the day. That's not when the batteries were pushing to the grid their most. They were going for when the price was the highest, which in theory should be when we most needed that injection into the grid. Just a couple of slides here to just kind of refresh everybody on the RTC changes. And this slide here is a picture of the current real-time market. The energy offer curves coming into the current market are coming from what we call this combo model. Our security constrained economic dispatch has a process, but it doesn't calculate a price for ancillary services for each 5 minutes, and there are no awards for ancillary service for each 5 minutes. I'm going to flip to the slide that shows how the real-time market looks under RTC+B. On the left side, you can see that there's some change. We're now using some AS demand curves. We still have this SCED process that's using offers, and in this case, the offers for the batteries are a combination of an energy bid to buy and an offer to sell offer curve from the batteries as a single submittal. And another key output from this SCED process, once we have RTC+B implemented, is every 5 minutes we have an ancillary service award, and we have an ancillary service price for each ancillary service. So batteries, again, playing a key part in the ancillary services. This is a significant change for how the batteries are used in our system. High-level scope of +B. So here I've listed 5 nodal protocol revision requests that make up the bulk of the scope of the +B part. We'll just go through them quickly. 1014 is the Energy Storage Resource Single Model NPR that was developed during our Battery Energy Storage Task Force back in 2019 and 2020. NPR 1204 came a little bit later. It takes into consideration the state of charge and the real-time co-optimization implementation. NPR 1236 is where we introduced RTC+B modifications to the RUC capacity short calculations. Item 4, we had some terminology alignment that we did through the protocols, the nodal operating guides, other binding documents, and that NPR covered those items. Item 5 is NPR 1282, ancillary service duration under real-time co-optimization. That was recently approved at the ERCOT Board of Directors on June 24, 2025. Still waiting to be considered at the next PUC meeting. We'll talk through all of these a little bit more later. And then I also wanted to point out that originally in our first go at installing the RTC+B project, we had included NPR 1029, which addressed DC coupled resources, hybrid resources, for example, PVs plus battery seen as one resource. When we restarted the work on RTC+B, we decided that that was not necessary to include in this version. So that is not part of the RTC+B project, and that is the 1029 DC coupled resources is not part of the RTC+B project. Okay, we're going to go a little faster. This is part of 1014. It's about the single model. You know, basically, and we'll go through this some more, registration, qualification, modeling, telemetry, energy bid offer curve submittal, performance monitoring, settlements, entry into the outer scheduler is now moved to this single model. Here's a graphic of kind of the evolution that we're making here. Row A is the combo models, what we've been doing since 2012. Everything is registered as 2 resources, and all the systems see it as 2 resources. What we are planning to do with this implementation in RTC+B is move to row D, where it comes in and registered as a single resource, seen by all of our systems as a single resource, and there should be some simplification for both the market participants and for ERCOT in dealing with these resources. And note, to make this transition, we had to strategically say, once we get to the single model, we need a new name for these existing energy storage resources that are due to come online soon, shortly after the RTC+B project is implemented. So we've created a new set of names for all the energy storage resources, new single model names, and this link here can show you the list of that name, the list of those names. And there's roughly about 275 energy storage resources in the system now. Here's a quick picture of how it looks in the modeling, and this picture is what we have today. The part in the yellow square is the controllable load resource, and then also the generation resource. And we see those two together. That is the energy storage resource. And in this picture, you can note the locations of the 2 meters, meter 1, meter 2, and also the resource node. And in this particular site, which is a typical generation transmission connected energy storage resource, at this site, there's 2 other wind generators there. Again, the battery is separate from those wind generators. And now when I flip to the next slide, here's the same picture, but now it's represented as a single model, which is what it really is. It physically is a single model. And when we make this change, we don't have to move the meters. There is no change to the metering. There's no change to the wholesale storage metering. There is no change to where the resource node is located. It's just that we're now seeing this truly physical single device as a single resource in our models. Briefly, there is a registration process that we have gone through and are still kind of finishing up, where we're transitioning the existing information we have into the single model. Here are a couple of references to help you through that. Again, I think most of the existing queasies, qualified scheduling entities, with energy storage resources have followed this process and are well on their way to being in the market trial system as a single model. Ancillary services qualification. So there are some things to note about how we will have to update some information on the issue of ancillary services qualifications for each ESR. This first link is a link to a recent June 20th PDC working group meeting where we talk about how this AS qualification transition to ESR single model will occur. And then I would also note that there's a scheduled meeting on July 23rd where we also plan to present more information on how that transition needs to occur. Assuming NPR 1282, the ancillary service duration under real-time co-optimization, is approved by the PUC, and this NPR has already been approved by our board, there will be some changes we'll have to make to the qualifications of the energy storage resources. Also note that there is a potential need for the ESRs to resubmit forms to update each ESR's response reserve service % limit. You want to pay close attention to that change. Okay, a quick slide on the energy bid offer curve, current operating plan, and telemetry. As we talked about before, this energy storage resource is be seen as a single device, and it covers the entire range from the low sustainable limit to the high sustainable limit. And that low sustainable limit, the maxing charging megawatt, is a negative number, and the discharging megawatt is a positive number. We're going to continue to require queasies to provide hour beginning state of charge information for future hours in the COP for the ESR. The telemetry for the ESR is as a single device. I have a slide on that later. All ERCOT systems are seeing it as a single device, and this implementation of the single model will eliminate extra coordination that's currently being handled by each queasy and by ERCOT. So that should reduce the administration for ERCOT and the queasies. This slide tries to provide a little bit more information, visual information on the energy bid and offer curve. Forget about the left, that's what we're doing today. On the right shows what we're doing with the single model, and it should be monotonically non-decreasing from the maximum charging megawatt negative to the maximum discharging megawatt, which is a positive number. The maximum price on the charging curve is less than the minimum price on the discharging curve as a requirement. And you can have up to 10 pairs of dollars per megawatt hour and megawatt level. And this is a picture of a 100 megawatt plus or minus 100 megawatt battery here. Telemetry, the far left, that box, those are the state of charge, the 5 state of charge telemetry points that we implemented back in 2018. Not any changes there. We're still expecting to get those. There's some other ESR telemetry that we get today, and there's some changes there. There's another YouTube that goes in more details of all the telemetry. But the key thing to note here is that now LSL, low sustainable limit, can be a negative number. And the net megawatt can be a positive number when it's discharging and a negative number when it's charging. And same thing with the gross megawatt. A couple of key things we wanted to implement, or we wanted to bring to everybody's attention with the implementation of RTC on telemetry. The main reason why we're bringing up this issue is there is a change as we go to the single model where the tolerances or the energy storage resources and how it follows its set points is tighter with RTC+B than it is today. So we want to make sure everybody has their telemetry correct, especially when the battery is charging or receiving a base point of 0. And that first bullet there is when you're charging or receive a base point of 0, you should not include internal losses in the battery, electrochemical and inverter losses. And note that the net megawatt charging or discharging represents the energy storage resource response to its updated desired set point, plus any frequency response at the point of interconnection. Therefore, this net megawatt telemetry when the ESR is discharging includes the internal losses in the battery. And the gross megawatt telemetry is the actual charging or discharging megawatt as measured at the model terminals of the ESR and include all internal losses in the battery, including the losses when there is no expected injection from the ESR could lead to set point deviation charges that may not be appropriate. So make sure you get that telemetry correct, especially when you are charging or you have a base point of 0. And then again, with the implementation of 1014, there's a tighter tolerance on the set point deviation tolerances. We'll go through that one more time, I think. All right, this slide here is a quick presentation of the duration, AS duration under real-time co-optimization. This is essentially NPR 1282, recently approved by the board. And the table at the bottom shows the 3 different places or time periods where we are using a AS duration. So there's the qualification, which is shown in the middle there. There's the real time, and there's the RUC. This is what we've said the duration is for the qualification for each of the ancillary services. Regulation 30 minutes, response reserve 30 minutes, ERCOT contingent reserve 1 hour, and non-spinning 4 hours in terms of qualification. So when we do that qualification, we're going to look to see at what output level can you maintain the service. And for non-spin, it will be in this case for 4 hours. We also are using those same AS duration numbers when we do real time. And that will be something that SCED will use, security constrained economic dispatch, of when it's checking to see how many megawatts of non-spin could you be rewarded. It's going to use this 4-hour AS duration number. I would note that there is still some discussion on this. It's highly likely that we'll use these numbers to go live with RTC+B, and shortly after we go live, we'll reevaluate these AS duration numbers, qualifications in real time, especially for maybe non-spin. So that's a key part of this project, is incorporating these AS duration numbers. Okay, going back to the day-ahead market, I want to highlight a couple items there. The energy bids and the offer curves for the ESR is input into the DAM. And with the implementation of the single model, we'll now see these as resource-specific DAM energy sales and purchases that are cleared at the resource node of the ESR. So there's a change there from what we're doing today. And this is also important to note. Bullet 2 is the state of charge is not considered in the clearing for energy and AS in the DAM. Therefore, if Equizia is not careful, they could oversell its capability in DAM. DAM is not going to check to see if you have the adequate state of charge to make those sales that you've offered, if you offer too much. The ESR will be awarded DAM resource-specific sales, energy sales and purchases, and resource-specific ancillary service sales. And note that the fast responding regulation service, which was implemented back in 2012, is no longer a subset of regulation, and that's being phased out as we transition to RTC+B. And then there's a link here where we talk about, in the event that the offer curves do not span the full range of the LSL to HSL of the battery, and we have to convert those offer curves to have offers, bids to buy and offers to sell for the parts that weren't provided. And this link here goes through some examples of how we plan to extend those offer curves and bids to buy. Okay, now that was the day-ahead market. Now we're going to talk about the real-time market. And so these energy bids offer curves, single submittal for the ESR, and the ancillary service offers are input into the SCED process. SCED's running every 5 minutes. These can be updated anytime. Whatever is there when we kick off the SCED process, that's what we'll use in the calculations, along with other information to determine awards for energy and ancillary services. SCED incorporates an state of charge accounting within the optimization, and this is to ensure that the awards to the ESRs are feasible and there's sufficient energy to sustain the megawatt awards for the energy, which are the base points, and ancillary services for their respective SCED duration requirements. Again, SCED is just a look at the next 5 minutes, and so this is what SCED will do to determine what you can do for those next 5 minutes. And SCED will not violate the telemetered minimum and maximum state of charge values for the ESRs. So we talked earlier about if you're low on charge, we will respect that minimum state of charge level and not try to push you down below that with an energy award, for example. Okay, item 3, the awards for each resource are limited based on the resource's qualification, telemetered physical capabilities, state of charge information, ramp rates, duration requirements for each AS type. This is different from what we're doing today. Note that multiple ancillary service types and energy can be awarded to an ESR in a SCED execution. Also, this queasy management of ancillary services across a queasy's portfolio no longer exists. So there's no reason for a queasy to try to move its ancillary services. This RTC+B project automates all that and has ERCOT doing it, looking at all the possibilities ERCOT-wide of where's the best place to carry that energy in the AS. So that's something that goes away. This slide is just a couple of sections from the ERCOT protocols to highlight again that we're changing the set point deviation tolerances for when you overperform or when you underperform. Just keep that in mind. Make sure your telemetry is how it needs to be. So the concern is that maybe your telemetry today is sliding under those tolerances, but tomorrow, once we have tighter tolerances, you may start getting set point deviation charges, and we want to make sure people have their telemetry correct. Okay, a couple of slides left. We're moving on to RUC. The day-ahead RUC and the hour-ahead RUC will be the tools that ERCOT uses to assess if enough capacity is available and in the right locations to ensure the RTC SCED will have enough capacity and state of charge to solve for energy and ancillary services. So the RUC process is looking multi-hours in the future. So it is our tool at this point to convince ourselves or to have us say we need to bring on more units if we see that we don't have enough units in the right place and we don't have enough state of charge as indicated by information from the ESRs. Similar to today, energy storage resources will not be seen as off and therefore will not be available to be RUC'd on. We're assuming they're on, so there's no chance we will say, try to RUC you on. We expect ESRs to have a status of on out, on outage schedule, on test, on emergency, on hold, or out. Out should only be used if the resource is broken. And then in evaluating the capability of online resources and those shown offline, the full capability of the resources, including the ESRs, planned to be available will be fair game for the RUC software to find energy and ancillary services. So today, we make an assumption that based on the responsibilities from the day-ahead market, this is where the ancillary services will be carried. Tomorrow in the RUC process, that RUC process will have the liberty to say, here is all the different places I can have that ancillary services. Here's all the different places I can have that energy. This is the best way to do it. So again, we're making a change to this RUC process to evaluate where is the best place to carry these ancillary services in future hours. Again, this RUC process is a simulation to see how we look in future hours. A key thing to keep in mind is the RUC software will use the hour beginning state of charge information that's provided by the queasies in their COPS for each SR to appropriately limit the possible use and capability of the SR. So if we see in a future hour that your 2 consecutive hour beginning SOCs show no change, then we don't see that your thinking that you're going to push or have the capability to push much to the grid. And that will be considered in the RUC process. So the RUC process self-schedules these energy storage resources to their hour beginning state of charge. It evaluates the change in the COPS emitted, hour beginning state of charge, and across 2 consecutive hours, and determines the best use of that change in energy, combination of charging or discharging the energy storage resource as base points and or procuring ancillary services, considering deployment factors for that hour. So with this RTC+B project, we are introducing a new feature called deployment factors, and they are used to simulate the deployment of ancillary services for an hour. It's something our operations group will prepare and share with people of here is our projection of the deployment factors, which could be 0, 1, or between 0 and 1. 1 being like, yep, we're definitely going to deploy non-spin, for example. 0 means nope, it's not likely we're going to deploy non-spin, and then some place in between there. There will be a projected deployment factor for each AS and for each hour. We're using these deployment factors in the RUC process. We're not using these deployment factors in the SCED process. And then item 6 is the RUC capacity short calculations use optimization techniques to minimize a queasy's potential energy and or ancillary service shortfall. So we're going to find what is the best way from a queasy's perspective to lay in those energy and AS and other positions that you have to calculate whether or not you're short. Again, we'll consider the COPS emitted hour beginning state of charge and other information, trades, capabilities of units to see whether or not you're short, and we'll give you pretty much the best picture you can have. And this is important because this concern of whether or not you're short in the RUC process is a driver for you to make sure that the ancillary services that you have a position on, that you have them covered. And you know that if you don't have them covered, that you can be determined to be short for hour ending 19, for example, on a RUC process that is run at 10 a.m. in the morning. If you are short, then that gives you a little bit different exposure to footing the bill for the RUC costs for that hour later in hour ending 19. So that's the process of doing these RUC capacity short calculations, is to see where and which queasies are short and first apply those short queasies to cover the costs for that RUC, and then at a certain point we move to load ratio share. Item 7 here is a couple of links to some more background information on this RUC capacity short calculation. Okay, that's the end of this presentation. Again, this has all the links that we provided earlier in the slide deck. Thank you for your attention.